So I'm gonna talk about water system modeling, pipes, nodes, and flow rates. I am Gianni Varona, and for this case, we have the design criteria. For example, the NEC 11 chapter 16 and the NTE INM 1108 2011. And the other one is International Plumbing Code EPC 2024, and some design objectives, for example, safe potable water distribution, adequate pressure and flow, and compliance with regulations, and reliable operation. So we proposed some drawings, in this case for the water supply system. We have some notes in this case. Um, we draw the notes, for example, in two of the corner in the draw. Um, in this case, we have a table for the domestic water demand. In this case, it was a drinking water demand, and and we calculate for provision for use, people to serve, and we calculate total water demand. For example, we in this case we have 1,250 liters per day. The maximum daily consumption it was 0.02 liters per second, and the maximum hourly consumption it was 0.03 liters per second. We have some data. In this case, we have a tank at the total demand. Before that, we got it was 2,250, and the split time it was 1 day. In this case, we got volume 1.25, and we got a minimum water height. In this case, it was 1 meter. The area it was 1.25, and we have the width, the length, the border free, the free border, and the total height, the total volume. So, for example, on the table that we have the inlet, we have the velocity. It was the 1.5 meter per second, and the inlet demand it was 1.25 meter 3 per day. We have some data about storage tank supply time. In this case, it was for an hour. And for the house, we have the supply time, the Q tank, the diameter, the commercial diameter, the Q house and diameter, and the commercial diameter. We have all of those data on this table. We have also the equipment quantification. In this case, we have the nodes. We got the area. For example, we have the kitchen, two rooms, finally the room one. This case in the kitchen we have a faucet. In the other one, it was the sink, toilet, the shower, and we calculate the QI. And for those values, we got the factor 2. And after that, we calculate the QS, it was 1. And finally, we got the QO, it was 0.2. So then finally, we got the total node 1 plus 1. Okay, so and then finally we got the suction. It was the 0.67. So we calculate all the data that we have before on the drawings. For example, here. So all those nodes, we calculate all the the QI to get the QS to get the finally QO. And finally, we got the equipment quantification for pipe data, and we got the diameter, the Q, the velocity, the material. In this case, we got the PVC, and to get the HF for each node. It was in the first case, it was 0.0445. In the second case, it was 0.069, and then finally we got a 0.12. We can see we got the all the values, and the finally we got 0.224 for the AG. Thank you, Miss.